present us about yada, yada, yada.
All right. Well, this talk is called... I'm Malcolm Sparks. I'm here from a company called Juxt, who are based in London. We do a lot of consulting work for clients, but we exclusively use Clojure. We eat, live, breathe Clojure. That's all we do. And open source is very important to us. We have a number of libraries. Yada is probably our most important library, and I want to talk about it today. Why is this stuff important? If we look back 550 years or so, we see the Gutenberg printing press, which radically expanded communication amongst humans. Today, if we look back at 1990, I think historians will see the web as one of the most important discoveries or important inventions that humans have ever created. It's certainly created a huge explosion in the way that we collaborate and communicate today. And I think this is an incredibly important technology. The web is essentially three technologies. It's URIs, which took us a long time to get to. In computer science and enterprise systems, we took a long time to find a uniform way of addressing information. And once we were able to address information, we were able to retrieve information from those addresses. This is incredibly important technology, and it's one that made the web just happen almost overnight. And we're still seeing the ramifications of this today. The third technology is HTML, which was very important for bootstrapping the web because it allowed the web to be accessible by human beings. But HTTP is incredibly important because it's also the choice of a new generation. And this new generation is the machines, of course. I bought one of these Amazon Echoes. Has anyone heard of Amazon Echo or seen them? The things that you buy, you put them in your living room and you talk to, you say, is it going to rain today? And it says, yes, it will rain today in London, because it always rains in London. Or if you want to program one of these devices, you kind of create an Amazon account, and you have to write a service. And guess what? That service is HTTP. And you have to receive some JSON and you emit some JSON. And that's how important HTTP is. It's creating far more communication, not just amongst humans, but amongst machines. And that's why it is so important for us to implement the protocol correctly, as Billy was saying. And yet web frameworks today are still stuck in the past. We still have so many broken links. We still have frameworks or new frameworks, even recent ones, that approach the problem by saying, here is the request, now you go and figure out the response. Like every developer writing every endpoint is going to read every RFC and implement every single thing. It's completely overwhelming, and it's no surprise that developers only implement the bare bones of what they need to get their service to work. And back in back in the 90s, I think I was implementing standards. And when you implement a standard, you didn't really have a choice. It wasn't, just implement the stuff that you want to. In order to get interoperability, you had to implement all of it. And it's a real shame that we have HTTP services that are so lacking in compliance. So we need a better way. WebMachine and the Clojure implementation of WebMachine, Liberator, is certainly a way forward. And I used Liberator, and I was very, very keen and happy on Liberator, used it in many projects. So the two things that I wanted to experiment beyond Liberator was I wanted to, when I was using Liberator, I had to learn this decision graph, and I had to have it in my head. And I wanted to somehow get beyond that. And the Liberator and WebMachine is an execution model, as we've just seen. And I wanted to really make it more, bring up the abstraction so developers wouldn't have to learn about how HTTP is executed, but really just declare what their services are in data. And the second thing that I wanted to experiment on was how could I make this asynchronous? There have been experiments in making Liberator asynchronous, but it's a difficult problem, and I wanted to just solve it by writing something new. So I came up with Yada, and this was a couple of years ago, and I've been working on Yada ever since. It's had about 2 years of work. It's definitely a project that I'm invested in. I'm going to be working on it for many, many years henceforth. And so Yada is declarative. This is the great thing about Clojure for the web. The Clojure syntax is so beautifully simple. So when we create data and when we create functions and when we create code in Clojure, we just create it in trees. This has some benefits. It means that we can author it very easily. If you've ever authored things in JSON, I suggest this syntax is very similar to JSON, but it's much, much nicer to author. With JSON, you have to keep remembering to put your keys in speech marks and your colons, and you have to remember to put your commas in, and it's such a pain to author. This Clojure syntax is just so nice. There's no commas to worry about. You can have any keys you like. It has keywords. So this is a declarative resource. And just as we can see straight away that we have two methods, get and put. That has been declared. We can see the get method produces text HTML. And we can see that the response is a response of a hello world string. Likewise, on the put, we can see that it consumes JSON and that it takes a body parameter, which is a string greeting. Yada is standards compliant in that, like Liberator, it generates the correct response status codes and headers, and it implements all of these RFCs that I talked about. And there's more to come. One difference between Yada and Liberator is that Yada is linear. And it's a linear chain of interceptors which all look the same. And the idea is that you don't change this linear set of steps. For expert users, it is possible to change this interceptor graph, but it isn't like a framework like Pedestal where you say, well, for doing this JSON response, I'm going to put these interceptors together, and for doing HTML, I'm going to put those ones. And the reason I wanted to make it linear and fixed is because I wanted all types of HTTP endpoint to exhibit, so all of them to get content negotiation and conditional requests, and all of them to have security. I didn't want a kind of pick and mix model because I want all of the endpoints to be compliant. Why should one endpoint have content negotiation and not all of the endpoints? This is what an interceptor looks like. We have a function which takes a request context. It's very similar to Liberator, and it returns the context. This is a particular interceptor called known method. It actually says, do I have a method wrapper in my context? If I don't, I'm going to throw an exception. But because this is asynchronous, instead of actually you can throw an exception, but there is a way of actually returning an error. And otherwise, we just return the context. So there's no Boolean decisions here. We don't return a true or a false. We just return context. It may have changed. So Yada is also asynchronous. Every single one of these interceptors can return, instead of a context, it can return a deferred value. So it can say, this is a promise. I'm going to promise that I'm going to return a context or a future context. Or it could be a core async channel that closes with a context. So at any single point, you can decide, oh, I'm going to go off to my database now, and I'm going to return a promise because that database is going to take a long time. Yada is also extensible, and this is a very key aspect to HTTP. Yes, we have those 6 or 7 methods, but we also want to be able to add methods and media types too. It's very, very much an important aspect of the web that we can plug in new media types. We might come along and write a service with application JSON, but we might want Eden, but we also might want some application-specific media types. The point about REST and hypermedia APIs is that when we generate links in our responses and we want the machines to follow those links, we have to establish some sort of standard or agreement between us that those links mean, brew a cup of coffee, or this is how you get to another resource. We can give those links labels, but we have to define what those labels are. So the ability to plug in media types allows us to do this. If we then come up with a new version of our API, which has new links, we can define a new media type, and then an existing client that is just version 1 can negotiate and get version 1 of the media type. So it allows us to evolve and add new features and yet still support old clients. On the web, that's incredibly important because we don't control all of the endpoints, we don't control all of the agents. We want to deliver services that are going to be around for many years, and we don't want to force all of our clients to upgrade. That's not how the web works. And so pluggable media types is incredibly important. And power users can implement interceptors. Could I ask, could somebody get me a glass of water, because I'm going to lose my voice. If anyone has some water, or they can get me some water for 5 minutes' time, that would be really great. So this is how we add a method. Methods currently in Yada are done through protocols. There's a protocol called method. And if you want to add a new method, you have to extend a protocol. And then these are the protocol functions that you have to implement, whether the protocol is, whether the method is safe, idempotent, and so on. But here, every method has this is really the method wrapper, and you get the chance to put in your own semantics before calling the user-provided response function. So you can get to decide if the user function returns nil, whether you should return a 405 or a 203 or whatever. So this is where you can write your own method and put your own semantics in. Yada will call your request before, and you can do whatever you like there. You don't even have to do anything. Adding media types is done through multi-methods. This is one that was contributed to Yada, and it's a media type that handles transit, which is an optimal way of communicating via JSON. Yada is scalable. It's built on Aleph and Netty. Netty is a real gem of the JVM. It's a web stack that handles hundreds of thousands of concurrent connections. Thank you. That's great. Thank you. And it's used by big companies, Google, Facebook, and Apple, for some of the most demanding workloads. So when you deploy Yada services, it's not completely ring compatible in the box. It is assumed that you're going to use Netty. And I would like in future to relax that constraint. Currently, that's still part of the package. So let's have a look at some of these interceptors. Content negotiation. This is done right down in select representation. You can write produces text HTML, but I have a schema behind everything that you can put in a resource declaration. And if you were to put something like just a string, which is, I think, an easier thing to type, it will naturally become the canonical form, which is I produce a set of media types, a set of representations. This is a vector, and I'm saying one of those media types is HTML. But you can do much, much more. Imagine you had some HTML that was available in English and Chinese, and that was in UTF-8, but you also had a zipped up version which was in a different encoding. And you could say, well, I have another one, it's in Shift.jis, but it's only in Chinese, and it's gzipped. And then I can give you text plain in any char set that my JVM can encode in. And so you can make very, very complicated recipes for content negotiation, and Yada will do the right thing, and it will pick one of them, and it will make it available through the context to your methods that can then act on it. Parameter parsing, this is something that was introduced in, I think, a technology called Funhouse by Prismatic. This is where you use Prismatic schema to declare what kind of function, what kind of parameters you're going to pass. And those parameters could be query parameters in the URI or the path parameters. They could be in the request header. They could be a cookie. They could be in your body string. They could be a form, a web form. And so it's a very, very powerful thing to declare your parameters up front and say what they are. In here, I've declared a resource which has a get method, and the get method expects some parameters. There's a query parameter, one called foo, and it's expecting an instant, which is a schema value. This is a date. So if the foo parameter will come in the query, and then it will get coerced into a date if it's in a date format. So in your method implementation, you don't have to do these kind of type manipulations where you turn a string to a date, or you turn it into a Joda date and back to a Java util date, and all those kind of things that really clutter our code. You can declare it once as a query, and then it becomes a date. We'll see this body, same with this body request. This is saying I want a JSON, it could be a JSON body, it could be an EDN body. We want to have a key called intent and a subkey called name, and it's got to be a string. We'll see why later on. Conditional requests. There's quite a few interceptors that take part in conditional requests. One is called get properties. Now, resources in Yada actually have metadata, which you can say, so you can say a resource, does it exist? When was it modified? What does it look like? Who does it belong to? Security constraints. All of those is part of a resource's properties, everything apart from its body. And here we can say, well, I've given a value here that the last modified is now, and the version is the string. Now, what I'm showing here is another feature of Yada, which is called resource coercion. Here we're taking a normal string and we're turning it into a Yada resource. And this way we can take a string and we can just manufacture a Yada resource straight away. You could take any other Java type. You could take a datomic database and just say, I'm going to write the code that turns the datomic database into a Yada resource. So you can take any type and then on an industrial scale, take things that you've already written and just say, I want to expose them to the web. And you can write the adapter code to do that. So in this case, for the string, we're actually, this is a static because it's saying, the properties can take a value. You can also take a function, of course, which can be called, and then you could return a promise. So you could actually go back to your database and work this out from the database and return it. Security is implemented built in. There are a number of methods. Authenticate and authorize are separate steps. Authenticate cannot and does not refuse access to the resource. Its only job is to put something in the context, your credentials, and to say those credentials are now valid. In the case of JWT, it might verify the signature of the JWT token, but that's all it does. It's only authorize that gets the choice to say, do we stop now? Has this person got sufficient credentials? And the logic here is, if they're not authorized and they didn't give any credentials at all, we issue a 401. If they did give credentials, but they're still not enough, those credentials are valid, but they're not enough to get access to the resource, we issue a 403. And that is the logic. The reason why there's a get properties step in between is that whether you're allowed access to the resource or not may depend on the resource's metadata. For example, bank accounts. I want access to my bank account, so I might want to check that it's me accessing my bank account. But if it was Billy, I want to make sure that, if the owner of the account doesn't match the owner of the request, then I want to send a 403, a forbidden. And that's why the get properties is done there. There's a number of other two other ones which control. This is around cores, and these are the HTTP security headers, which I'll show later. Again, these are kind of pluggable, but mostly it's only for experts to replace. You can replace interceptors with your own versions if you have to, but it's not recommended. In the resource, this is what security looks like. You put an access control. You can say, I'm showing the basic scheme, and this is the extension point. There's a multi-method here, so if you want to put in your own extension points, there's built-in support for JWT, cookies, digest, basic, and OAuth 2, but if you've got your own access token scheme or something, then you can plug that right in there, and then you can define what else you need in the resource. The default authorization, again, you can plug in your own authorization schemes. The default one will actually look for the credentials, the roles key, and it will actually, on a method-by-method basis, check to see whether you've got the right roles. But that's my own, I suppose, naive implementation of role-based security. You can plug in your own authorization. Server-sent events, very, very straightforward. This will do it. All you have to do is return a manifold stream or something that can coerce into it. So this is a core async channel. If you return just the core async channel or something, then that will become a long-lived connection. And you don't have to worry about that. That's all the code you need to do server-sent events. It's extremely easy to do asynchronous stuff because everything is based on an asynchronous backbone called manifold. So this stuff is really easy. Something I worked on this time last year, and it took me a long, long time to get right, was processing inward content for if you're posting videos or uploading form details. I wanted to make that very asynchronous, so it was possible to upload and stream very, very large videos, and you could create a YouTube-like site with this. So I had to make sure it was asynchronous, and I had to implement, I wanted to implement multi-form data. So there's a lot of code around uploads, which has full support for very, 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 very performant uploads of data. You can plug in your own error handling. I talked about the interceptors being linear. It's linear except for the fact if there is an error, you have a separate error execution a set of interceptors that are used just for errors. You have the ability, although it's not particularly mature, you have the ability to say, well, if I get a 404, and this will generate me a 404, then I want to replace the implementation with something else. So I want to handle the 404 in a different way. So routing is not supported. When you hear people talk about their web frameworks, they often talk about routing at this point. How do I get to these resources? And I had a conversation with Billy about 3 years ago in Berlin, and I asked Billy, when are you going to put routing into Liberator? And straight away he said, no, I'm not going to do it. And without even thinking about it. And that's quite curious. Why does a web framework not need to have routing? And so we got into a conversation, and really Billy said that a resource and a resource's identifier are really two separate things. And we very often complicate our programs by putting meaning into the identifier. All the meaning should be in the resource itself. And the identifier, in terms of the Internet Engineering Task Force, they see the URI as an identifier that simply locates the resource. Everything in the path and the forward slashes and so on is just conventional. It shouldn't dictate whether it's a JSON resource or something else. You should just treat it as a string. So, and the other thing that Billy said is that he wasn't too interested in any routing technology that didn't have bidirectionality, in that in order to create hypermeter APIs at an industrial scale, we've got to start hard coding links or trying to do string manipulation to creating our hyperlinks. And so he said he's only interested in something that could go both ways, from a URI to a handler, and from a handler back to a URI, so you could generate all of the forward links in your responses. So I thought about this, and I asked Billy for months and months, why haven't you written it? And he said he was busy and so on. So a couple of months later, I kind of, on the Christmas break, just decided, right, it has to be done. So I spent a couple of days writing what became bidi, which was just a URI router and nothing more. So this is really how bidi works. It's a data structure. Clojure loves data. We have all we have is a recursive set of pairs. The left-hand side of a pair is always something to do with the URI itself, the pattern, and the right-hand side is either a keyword or a handler or a vector of pairs. So here's another vector of pairs. So here we have /phonebook, and if we don't have anything else, then we get the keyword index. If we have another slash and then an ID, which we say we're going to destructure a value out of this, then we have an entry. So we can go from phonebook. If we go to phonebook, we get index. If we get to phonebook 123, we get to entry. And we can go the other way around. We can go index takes us to phonebook. And if we say entry and give it an argument of 123, it's going to generate us this URI. And that's all bidi is. So Yada is evolving. The next version I'm working on at the moment, I mean, I'm trying to keep binary compatibility, but at the same time, I'm trying to migrate from prismatic schema into Clojure spec, and that's changing a few things. I'm very interested in using Clojure spec to generate tests and test resources for my own testing and for user testing. I want to improve the instrumentation. I want to make it possible to take all of these interceptors and lift them, through, in a sort of monadic sense, lift them into a new execution path, so that there could be much more monitoring the entry and the exit of each interceptor. You could put some tracing in there. I also want to make sure that is only done, that you can do that in development time, but in production you don't take the cost of all of that. So I want the ability to take a handler or a resource and say, run this in production mode, where you don't have, where performance is the thing that you're trying to optimize, but also run in development and debug mode, where you can take all the instrumentation. And also things like stack traces, when you have errors in development mode, you want to see everything, all the stack trace and all of the problems and all of the tracing instrumentation. But in production, we've often put Yada into production, and that's the first thing that people say on security pen testing. They say, you've got to turn off the stack traces, you're revealing too much. So the next version will allow you to have a profile which allows you to say exactly what kind of things you're trying to optimize, and things you're going to turn on and things you're going to turn off. There is, next year, I have looked at implementing HTTP 2, so that's definitely on the roadmap. And then potentially rewriting Yada in ClojureScript or porting it to ClojureScript. There's been a lot of activity recently about running ClojureScript on Node.js and Apache, AWS Lambda, and all those things where you have very, very fast, single-threaded resources. And I'd like to bring all this HTTP stuff to those resources through the same framework. So I'm quite keen on doing a Yada version in ClojureScript. So putting it all together, this is what it looks like to program the Amazon Echo. All Amazon requires is that you have a resource that you can post into. So when you say, is it going to rain in London, to the Amazon Echo, it will post to your URI some JSON. And you have to produce some JSON, so these are the declarations there. Because the body is some JSON, we can then go down the various keys and we can pull out the intent. The intent is a kind of a single, the intent means give me the weather in London. You can get that intent by saying, is it going to rain, or give me the weather in London. There's a whole load of vocal models that you compile, but essentially it boils down to one intent with some parameters. So we, as a bit of fun, we created an intent called woodchuck, was an English phrase, how much wood would a woodchuck chuck if a woodchuck could chuck wood? And we wanted the echo to say, if a woodchuck could chuck wood, then I suppose a woodchuck would chuck as much wood as he could. And we had some fun with that. And if the voice model didn't work, we wanted to get a kind of a catch-all where the echo said, I'm a teapot, and that was a lot of fun. And we were able to do this with the family, just playing around. And it was easy because it was so quick to write HTTP services in this declarative approach. Okay, so if you want to get started, you want to know more, then 2 websites to go to. There's jux.pro/yada. That has all the documentation There's quite a complete manual. And then there's a sample application called Juxt Edge. I don't know how much time I have, but feel free to leave if you need. I've got 5 minutes, so I'm just going to show you what that looks like if you cloned this Edge repository. Edge is a sample application we've built that uses Yada and uses bidi and uses a couple of other GitHub libraries that we've written. So let me get to. So if you run Edge, this is what you get. On localhost 3000, you get a web page, and what you can do is here is click on Hello World, and that gives you Hello World. And of course, when you boot up this application, this is the root here. So this is a bidi pair. On the left-hand side, we have the pattern that we're matching on, and then we say hello world. So I can change this to hello this, or I can reset it, and then we're going to change it. And this is kind of what your workflow wants to be. This is very quick. Let's make some changes, let's iterate, let's experiment. We also have a full ClojureScript compiler process going on. We have a browser REPL there as well, so you can do ClojureScript apps. We have a ClojureScript app as a demo called Phonebook. So this is our Phonebook, which is written as an HTML application, and we have a ClojureScript version of it, which is more dynamic. When you interact with it, you'll see network calls being made, and then you can see that this is a put into the Phonebook. So just quickly, I'll show you there is a Swagger API as well. This is generated. This is sort of shows you how you can create a Swagger API. So I put Sparks in there, and there we have my name and my entry. This is exercising the same functionality here. So let's have a look at the Phonebook code. This is a more substantial resource here. So we have Yada resource. Here we have a producers. Can you see that? So this produces HTML, EDN, JSON. I've got some quality values here. So this is giving you a preference. Your server can say, I prefer to give HTML, but I will give EDN and then JSON in that order. I've got some transit in there as well. And then here's the query. This is the get method, and it has a parameter called query, and that's optional. If we don't put the Q value in, we'll get all of the entries. If we do, then it will do a search. And you'll see that down here. If Q, then search the entries, otherwise get the entries. And here we ask for the content type. If it's HTML, we render the Phonebook. Otherwise, we just return it. And this is a closure vector. And then Yada itself will coerce this data structure to JSON, to EDN, as you want. So the last thing I'm going to show is, there we are, that's the HTML version. If I use curl, there's the HTML. Let's give it a header of EDN. There we've got the EDN, so JSON. If you look at the, it's saying the vary header is set for you. It's saying that yes, I can change media types. Accept means I can give you different media types. And then we can have, let's have one more. We'll give it a method called brew. There we are. Well, it doesn't understand brew, so we're getting the 501 not implemented. But we're also getting JSON here. Why are we getting JSON? Because that's what we've set the header to. So the error is implemented in JSON. If we change that to EDN, so it looks like a stack trace, but actually this is an EDN rendition of the same error. So that's Yada, and if there's any questions, I'm done with my talk. I think we're ready for lunch or coffee break or something.